Did you know we can use your academic career to help explain climate change? If you missed part 1, I would suggest checking that first. Otherwise, you might be confused at why I'm so frustrated at averages. Consider your grades in school. When you complete a class, all of those assignments, quizzes, projects, and tests are grouped together in an overall class grade, which is basically a temperature reading of how well you did in that class. Weather in this analogy is kind of like if you stop to check your grades at a given point in a day. If you just received a great test score, then sunny skies, but maybe you didn't do so well and it's raining. In the United States, about every 4 years you complete a school, either elementary, middle, high school, or a college degree. At the end of each of these 4 years of schooling, you can calculate a grade point average, or GPA, which is like an educational climate reading when you think about it. To help with this metaphor, I've mocked up 16 years of randomized grades. It's worth acknowledging that not all schools are the same, and not everyone has 4 years at each school, or even gets a GPA at a young age. But it's useful for this metaphor, so stick with me. If we average all your GPAs, we can call this your global GPA, as it's similar to the global average surface temperature. We can then take each 4-year climate GPA and measure it against your global GPA to see if you did better or worse than your average. Do you remember all those assignments you didn't turn in 5th grade? No, you don't. And your global GPA hopefully doesn't reflect this either. To show how averages can be misleading, if your grades improved over time, your global GPA wouldn't be that different from someone who completely failed middle school but did perfect every other year, or someone who was consistent over their entire academic career. This is because averages mask extremes, and it's the same with climate data. Your area may be a little warmer or cooler than average today, but you probably don't notice. But what if you got an additional 2 points added to your temperature reading for every class in your academic career? Your numbers start to look a lot different. Remember the hurricane example from last video? We've only seen a small increase in global average temperatures, but we've had some pretty extreme results. Unlike GPAs, we don't want our global climate numbers to go up. That's because most things that exist today evolved to exist within a specific temperature range. Historically, when temperatures change, there are mass migrations and extinctions, and this is consistent with what we're seeing today. However, the current extinction crisis is largely driven by human land use and the rapid expansion of our resource-hungry population. Climate change is only exacerbating the issue. In the past, when climates have changed, it's not merely that a species can't adapt to warming or cooling. There are a variety of environmental pressures, including fewer resources for surviving species. And so there's a conflict over scarcity, which is detailed nicely in an open access paper by Cahill et al. Remember this. We'll come back to this in a second. For now, let's return to our main topic of climate change. This study from 2020 by Westerhold and a large team of co-authors gives us an unbroken, higher resolution look at past temperature records. Scientists put together a continuous global surface temperature estimate for the last 66 million years, also known as the Cenozoic era. To orient ourselves, evidence for the earliest hominid bipedalism exists about 6 million years ago here, with tool-making examples starting between 2 and 3 million years ago. Homo sapiens, our branch of the family tree, is thought to have evolved within the last million years here. As you can see, our species came into existence in the coldest period of the last 65 million years. According to the chart, about 4 Celsius or 7.2 Fahrenheit colder than the reference time period of 1961 to 1990. The study received samples and data from the IODP, the International Ocean Discovery Program, which is sponsored by the US, Japan, and EU, with additional funding from China, Australia, New Zealand, and Indian government agencies. But what does the future look like? Well, the table does include some forecast, named Representative Concentration Pathway, or RCP. Each RCP is a rough estimate based on possible future carbon concentrations. We can then use a 2013 NOAA estimate for RCP 4.5, which predicted that in 2025 we would have about 423 parts per million of CO2 in the atmosphere. However, a recent estimate by the Mauna Loa Observatory, which has been keeping records of CO2 concentrations since the late 1950s, reports in 2025 there are about 426 parts per million of carbon dioxide in our atmosphere. So we're currently exceeding forecasts of an RCP 4.5 world, which predicts 2.3 degrees Celsius or 3.6 to 5.4 degrees Fahrenheit of warming. This puts us on track to go back to the temperatures from the Oligocene or maybe even the late Eocene in only a few hundred years. If we look back to the graph, this dramatically rapid change would be represented by a vertical line. Back to our earlier topic of extinctions, each of these 3 points on the chart, the PETM or Paleocene-Eocene thermal maximum here, Eocene-Oligocene extinction event here, and the middle Miocene climactic transition here, correlate with some kind of mass extinction on the planet. Humans did not evolve to exist within the future temperature range we are headed towards. In fact, there are already plenty of examples that climate migrations have started. If resources become scarce in the future, it won't be 2 animals fighting over a carcass. It'll be nations deploying their full military might to secure fertile land and access to fresh water. Regardless if you feel like your home country would benefit from such a scenario, it would be horrific for everyone. But I refuse to end on doom. We can do a lot to mitigate the impacts of climate change, and there are millions of brilliant minds working on it every day. The more we do now, the better the outcome we will have in the future. Hopefully, you'll give this video a good grade. Thank you for giving us a bit of your day. If you like this kind of science and climate clarification, consider our written and audio articles on acidearth.world. Sources are listed in the description. Let us know if you have any questions or suggestions for future topics.